Hi, my name is Johan, and welcome in this second video about the Intel hardware innovations. In the last video, we talked about the GPU in the previous video. In this video, I want to talk about the combination of the different types of new hardware architectures that Intel announced, as well as the different types of APIs and frameworks we can run within a virtual desktop. And in the last video, I also explained that I'd like to talk about the use case, which in this case is a developer. So the developer could be an ML-based developer, doesn't really matter, utilizes virtual desktops to work centrally, to work securely, and to have access to their developer desktop basically from anywhere in the world. So we utilize the Horizon platform, the VMware Horizon platform to do so, and those virtual desktops are running on top of a host. In this case, what you can already see in the drawing is that the host has physical hardware, so CPUs based on the Sapphire Rapids architecture, GPUs based on the Intel Flex or Intel Max type of GPU series, as well as a VPU. And a VPU in this case is a video processing unit. Could also be an FPGA. Doesn't really matter, but the whole idea of the drawing and of this video is that I would like to show how OneAPI and OpenVINO are capable of utilizing those different types of hardware accelerators and use that from a developer perspective. So this is the starting point. I created a virtual function that actually assigns the different components to a virtual desktop. And within the virtual desktop, OneAPI as well as OpenVINO as a framework and an OpenAPI have been installed. Now, what Intel recently announced is something they call the Intel Dev Cloud or Developer Cloud. And it's basically a platform where you can download frameworks, you can download or pull completely built containers, but also additional components that belong to OneAPI. So let's if you want to use different types of libraries or different types of frameworks that utilize OneAPI, you can also download that from there. So libraries. Right, so what you ideally do is when looking at a user is that you, in a process, pull a Docker image, and that Docker image already contains libraries, frameworks, basically everything you need to, from the get-go, start a application and do something with that application. The application is based on something we call a Jupyter notebook. So what you basically get, if you pull that container, you run it on top of the, in this case, a virtual desktop, but could be any platform for that matter, is within that virtual desktop, you open up a browser. So that's a browser. And within the browser, you access the virtual address of the Docker image, of the Jupyter-based Docker image. And what then happens is you basically get a web-based IDE where everything you need is preloaded. So you could basically start coding immediately. And whatever function you need from an ML perspective is already there. So all libraries are there, are preloaded. Everything you need is there. Now what happens next, and I think this is really awesome from the OpenAPI API and the combination with OpenVINO and the different types of hardware accelerators there, is that if you look at the process of accelerating such a workload, is that, for instance, take a framework like PyTorch. This would be one of those frameworks that's part of the Dev Cloud. Now, if you have a script that you have in Git, for instance. So it's a Git-based script that utilizes PyTorch. What the OpenAPI and OpenVINO, OneAPI and OpenVINO framework do. So OneAPI, OpenVINO, is they are already fully capable of utilizing the right type of accelerator for the right type of job. So traditionally, what you would do is just push everything to a GPU, utilizing, for instance, the CUDA framework. But what these two combined will do is run the script or the application that you built on all three of those accelerators based on what you need. And the result is that you could create the same, you can get the same result in the same, maybe the same performance, or like in the same time frame as you would do with a CUDA-based workload. But it didn't, in this case, like a GPU might consume much more power than a CPU does. Whereas maybe a VPU would even consume less power. So OneAPI and OpenVINO will utilize the right type of accelerator based on what in that moment on you would like to do. So together they form basically a team of components, of accelerators, of chiplets, if you will, that will execute those calculations in the best way possible. And some of those calculations, some of the results, might be it might be better to execute them on a CPU, whereas others might be better to execute on a GPU or a VPU, or even combined. So I think this makes a great team of components. And it's not just Intel that does that, right? So if you look at how Apple is building their own silicon, they created different types of chiplets in the ARM architecture or next to the ARM architecture that do something really specific. Like they have ML types of chips. If you look at what they're doing in the Vision Pro in their newly announced VR headset or AR headset, is that they have different types, like maybe 4 or 5 different types of chiplets, and those individual chiplets do something specific and give the result back to the operating system. So Intel is doing the same thing with these different types of architectures, and they do it really well. So the combination of, in this case, Sapphire Rapids, so their latest architecture that fully supports this, as well as the Flex and Max GPUs, and VPUs in this case combined, give you a great solution to run those ML apps. So the main reason why we offer this from a VDI perspective is that we provide centralized access to large data sets. Data gravity in ML is really important, and especially when looking at large data sets that could be like several terabytes or petabytes of data, you don't want to have that decentralized. So keeping that centralized from a performance perspective is really important. Hence the choice for virtual desktops. Another reason is that you want to protect IP. So in case this is like the data sets that you utilize are based on your own IP, or maybe they're sensitive in terms of the type of data. Could be like patient data or something else. So from a security perspective, you want to keep that centralized as well. And when looking at maintenance of those desktops and high availability perspective, it's also a great choice to offer that centrally. Now, what we'll do in the next video, so there's going to be a third video, is I'm going to talk about again the VDI platform and the Flex and Max series. But I'm also going to talk about the endpoint, because quite often we see that the endpoint is undervalued component of an end-to-end stack. And I think especially when looking at complex workloads with high frame rates, but also nowadays with maintenance, that's quite hard to apply to modern endpoints. We want to keep that as simple as automated as possible. So in the third video, we'll dive into how we can fully integrate this into an end-to-end stack, where we also put focus on the type of endpoint. For now, thanks so much for watching, and I'll see you in the next video.